So let's take a look at how we can do point groups. How can we assign point groups looking at these symmetry elements that we just learned about in lecture 4A. So when we're assigning a point group, one of the things that we need to do is to identify all the symmetry elements within that molecule, but we'll do so in a flow chart. Or you can refer to a table to find out what elements are included for each individual point group. So here we have a couple different ways. We have a table here that lists various point groups here. So C1, C2, CS, C2V, C3V, C infinity V. These all sound kind of foreign, I know. You'll get used to using these terms as we start to get into symmetry a little bit more. So these are the symmetry elements that we talked about. So C1 has only an E symmetry element. In other words, you can't do any rotations, any reflections, anything on it and get back to this molecule. And this is because it has all four of these atoms here are different. And so if they're different, then you can differentiate them from each other and you can't do any kind of rotations. Something like a C2 point group has an E and a C2 symmetry element. A CS has an E and a sigma element, so it has a mirror plane there. But you can see as you go down, every single one of these has an E, and that was something we mentioned, is that every single molecule has an E because that's an identity. Now, one of the more common ways that we use to assign a point group is through a flowchart. And these flowcharts are pretty well thought out. And here, this is one of them here. So you take a look at your molecule. You look, is it linear? If it is linear, does it have a center of inversion? If yes, then it's this. If no, then it's this. And so you don't have to go through all the various operations to see what is the point group of that molecule. If no, then you just have several more answers to go through, and we eventually get to what point group we're going to deal with. So let's take a look at some practice. I'll do the first one for you here on the slide. So we're going to look at H2S, assign its point group. And then I certainly invite you to look at CO2, SOCl2, BF3, and C2H4. If you want to know the answers to see if you got those right, you can certainly look them up online and find what their point group is. But let's go ahead and do H2S, and we'll do it with this flow chart here, which is the same as the more colorful flow chart that was earlier, but this one reads a little bit easier. So first we have to write down the molecule, and we do need to know the geometry that we're dealing with. We know that H2S, if we can just go through and do a quick Vesper, and we see that it does have a bent geometry there. And we can use that geometry to help us determine what our point group is going to be. So we start at the start. We want to know, is the molecule linear? Well, clearly the molecule is not linear because we know that it is bent. And so we are going to be going this way. So you follow down here. The next question, does it have two or more CN axes with n greater than 2? In other words, does it have two or more rotation axes where n is greater than 2? And the answer here is no. It does have a C2 axis. That's all it has. But it does not have any axes where n is greater than 2. I can't rotate this molecule in any way to get back to this same molecule with an n greater than 2. So here my answer is no. So I come down here. So now it wants to know, does it have a CN axis at all? And the answer here is yes. And the reason it's yes is because this molecule does have a CN axis. It has a C2 axis. And the C2 axis runs right down through the center there. Okay, so if I were to rotate this molecule this way, and that one goes back that way. If it's a C2, that means I would rotate it 180 degrees. And if I rotate it 180 degrees, this hydrogen comes over here, and this hydrogen comes over here, and I still have the exact same picture. And so that tells me I have a C2 axis. So our answer was yes. Now we're going to go down here. Are there n C2 axes perpendicular to the principal axis? So this is our principal axis here. And it wants to know, do I have N, which is 2, do I have 2 more C2 axes perpendicular to the principal axis? And the answer here is no. I have no other rotational axes, and there's nothing more, there's certainly none that go this way or coming out of the plane of the screen this way. So my answer here is no. So come down here. Is there a horizontal mirror plane? So is there a mirror plane that would be perpendicular to that axis, to where I can reflect the molecule across and I would get the exact same picture? And again, the answer is no. I can't do that. So we're going to move down this way. Are there N vertical mirror planes? And here the answer is yes. Okay, because I have a mirror plane that can go here. And so what that basically does is reflect this hydrogen over to this one. It reflects this hydrogen over to this one, and it reflects this half of my sulfur atom to this half of the sulfur atom, and vice versa. Okay, get that out of there. Okay, and then I need to have 2 vertical mirror planes, because it says, are there N vertical mirror planes? And my N value is 2, because of that 2 right there. That becomes my N. So I do have another mirror plane, and it's in the plane of my screen. It goes like that. And so this half of this hydrogen reflects onto the other half. This half of the sulfur reflects onto the other half, and this half of my hydrogen reflects onto the other half behind my screen. So I have half the atom in front of my screen, the other half of the atom behind my screen, and the mirror plane is in the plane of my screen. So the answer here is yes, and because it's yes, they didn't put in a Y here, my symmetry and my point group is CNV. We said that N is equal to 2, and so that goes to C2V as my point group for H2S. Hopefully that helped going through that. I certainly invite you to use this flowchart to go through those other molecules that are in the practice, and write down your answer and then check them online to see if you have them correct. If you didn't get something correct and you just can't figure out where you're at, make sure that you contact me, send me an email, or come see me in my office and we'll go through it.